lecture series so far. In the first instance, I looked at the linear higher order homogeneous with constant coefficients. In this scenario, we are looking at the same procedure, but the difference here is non-homogeneous with constant coefficients. And I want to show you something on the slide, that is slide 17. I've already explained when to have a homogeneous term, and when you have non-homogeneous term, we've taken examples on that. Now, if it's non-homogeneous, it means there's a source term, which is the GT. Because of this source term, we have a solution method for that. The solution method for non-homogeneous is such that you find the homogeneous solution, and then you have some particular solution. YC is a solution obtained from the homogeneous part. It means you set it to 0. YP is what we get from the non-homogeneous part. Now, there are two ways to solve this method. One way is to use the method of undetermined coefficient, as you see in slide 17. And then the other method is the variation of parameters. So I'll use VOP for short, MOU for that. The next thing is, when do I use either of this method? You can only use MOU with some specific GTs. So when your GT is a trigonometry, in that case you have just the two forms of trig, cos and sine. If it's a polynomial, you are good to go. If it's exponential function, you are good to go. Or it is a linear combinations of all these types. Anything apart from, so I'll say anything else, you use a VOP. And so we can say that the VOP is an extension or a general case for solving MOUs. What MOUs can't solve, VOP can. So extension. So you can have functions like len, you can have tan, any other functions aside what is listed here, you are good to use VOP. That is the only difference. So that's explained in slide 17. So I've talked about this thing. So if you have sec and absolute, you use the VOP. Now let's look at method of undetermined coefficient. And pardon me, this might be a long video than the usual short videos I do because of the computations involved. But I'll try my best to have it in few minutes. Let me take MOU. Oh no, this is no good. Method of undetermined coefficients. There are some steps you need to follow. So I've already discussed the special cases of all these things. What are the steps I need to do? So 1, find your homogeneous solution. And that gives you the YC. It means you set your differential equation to 0 and then you solve. You find the roots. Don't forget, in this case, you are using the root technique. Whether it is real and distinct, repeated, complex, you write your solution. The second thing to do is to find your particular solution. When I say particular solution, I'm implying the non-homogeneous part of the equation. That is your GT. So YP is your particular solution. That depends on what you have in your source term. Now, how do we define these YPs? YPs are mostly a copy of your source term, or other textbooks call it, they are the trial functions of your source term. Other textbook uses the word they are guess functions. of the source term. Now we must check something here before we agree to our particular solution. So let me call this as checkbox. You must ensure that the guess solutions for your YP are not the same as what you have in your complementary solution. If it's equal, it means if there's a solution which can be seen in the complementary solution, you have to modify your YP. We'll look at how to do those things, but don't forget this checkbox. Your guess solutions should not be found in the complementary solution. If it's found, modify that. So the third step, assuming we've obtained our YP as a solution, what do? We differentiate, we substitute, we factorize some things, and then we compare the coefficient. That's the last thing to do. Okay, so I'll take an example. Don't forget these steps. I'll take an example on each and every category of our YP. So I'll take the first example on polynomials. When my source term is a polynomial, let's take a simple second order linear equation. Now this is a linear equation. It is a non-homogeneous equation because of the source term here. The order is 2, so it's a second order. The coefficients here are constants. Don't forget, I told the coefficient depends on the dependence variable. So the coefficient here is 1, here is -1. It is constant. Please do not think that because I have x's here, they are non-constant. These are the independent variables, which it's not of interest. So step 1, let's find our complementary solution. That is by setting our differential equation to 0. It means we neglect the source term. You find auxiliary equation. It will be lambda squared minus 1 is equal to 0. Lambda prime minus lambda equal to 0. And in that case, you have your root as lambda minus 1, lambda plus 1. So we have real and distinct roots here. Hence, my YC is equal to C1 negative X. It is in terms of X, not T. C2AX. This is my complementary solution. So I'll label it as equation star. I'll label the original equation as equation star star. Okay. The second thing, we must find our particular solution. It is a copy of our GT. My GT is giving us 2x squared minus x minus 3. If you want to have a copy of this, I will assume it as some ax squared plus some bx plus c. This is my guess solution or my trial function. If this is a solution, what do? You must test. Testing means differentiate, substitute. So I'll differentiate this one twice because the highest order in the differential equation is 2. Let me expand this and then have a very broad view. Okay. So the first derivative here becomes 2ax plus b. The second derivative, I get 2a. So equation 1, equation 2, equation 3. I now have to substitute into the differential equation, which was given as y prime prime minus y is equal to negative 2x squared. So you substitute 1, 2, 3 into star star. That is 2a minus ax squared minus bx minus c is equal to what I have on my right hand side. Now we can do some factorization over here, which it's already in a simple form. So the next thing is to compare the coefficients. Let me take that of the x squares. How do I compare the x squares? You realize I have negative a x squared can be compared to 2x squared, which means that a is equal to what? Negative 2. If I take the x part, I can have it as negative bx being compared to negative x, which means my b is negative 1. And then if I compare the constants, I'll have it as 2a. So this and that 2a minus c can be compared to the last constant, a negative 3. I already have a value for a, so I can simply find for c. That is negative 3 on, that's 3 on 4. Because here is negative, it moves to the next part. This is how I find my coefficient a, b, c. So it means my yp, which was ax squared plus bx plus c, is now negative 2x squared. B was negative 1, so I have here as negative x. And then c as 3 on 4. This is my particular solution. And so the entire solution for the problem is yc plus yp. The homogeneous part of the equation we had. Okay, I hope I've been able to capture that. So c1e negative x plus c2ex minus 2x squared. This is the new solution to the non-homogeneous equation. I hope this has been well understood. Okay. The second example, I've done the polynomials. Let me take where my gt is, let's take the exponential functions. So I'll still take a simple second order equation, y prime prime let's say 30e to t. So 1, find your yc. It means I need the auxiliary equation. I have to set my differential equation to 0. And then the auxiliary equation becomes lambda squared plus lambda plus 3 equals 0. So how do I find the root here? This might not be possible to do, so let me make it 4 here. So I get 4 lambda here. Then in that case, I can have these simple terms. So lambda 1 is 1, lambda 2 is 3. Hence my general, so my complementary solution is that this is in terms of t's, so don't forget it becomes t. This is the yc. As simple as that. Now the second part is to find my yp, Did I do my checkbox for the first example? Let's see. The guess function I did, you realize that it has nothing to do with the homogeneous part, so I'm good to go. There's no form of my yp in the homogeneous solution. That is my checkbox. Now let me check for the second example. Because my gt is 30e2t, I'm choosing a guess function as the form ae2t. Now I have to check it with my homogeneous solution. There's no form as that. So assuming there was something like c3e2t, it means there's another lambda 3 equal to 2 to have this. Then I can't use this as my guess function. It has to be modified. But in this case, I don't have such. And so I'm good to go. So this is a good guess function. I can differentiate it twice. I have 2ae. I have the second derivative as 4a. I do a substitution. So I equation 1, equation 2, equation 3. You substitute equation 1, 2, 3 into the differential equation. That is a non-homogeneous equation. The entire expression. It was given as y prime prime, if my memory serves me right. Alright, so let's do a substitution here. The second derivative is 4y. I want to just do a straight multiplication. That will give me 8. And then the last one just gives me that. You realize I can factorize this. In this second example, I can do some factorization. This is going to give me 4, 3, 7, 8, 15. And hence, by comparing this coefficient, my a is 30 over 15, which is equal to 2. This implies that my particular solution is just 2e 30. Wait, let's check what I had. It's okay, a e to the power 2t. So a has been found to be 2. And hence, therefore, my entire solution is yc plus yp. This is my entire solution. I'll take the last example on the trig. Let me take a new sheet here. So example 3. When my gt is of the form of a trig function, I'll choose let's take the sine. Let's do the sine function. So a simple example again. I'm still using a second order. So y prime prime minus 6y prime plus 25y is equal to 2 sine 4t. So this is a second order. So order is equal to 2. It is linear. It is non-homogeneous because we have this term there. It is of constant coefficient because the coefficient is 1, 6, 25. So I first find my complementary solution by setting the differential equation to 0. The auxiliary equation becomes square minus 6 lambda plus 25 equal to 0. What would be the root of this? This would be a complex root. We've solved this example in the linear homogeneous case, and then we had lambda to be 3 plus or minus 4i. So it means my solution here is e3t c1 cos 4t and then C2 sine 4t. This is my solution for the complementary aspect. The next thing is to search for your YP. Now my GT was given as 2 sine 4t. The guess can be in the form of A sine 4t. I always use A, but you can use any letter for your coefficient to be determined. So I check this with my, if I check this up with my YC, you realize that there's a term, C2 sine 4t is like writing A sine 4t. C2 is like A. So this wouldn't work. This guess function wouldn't work. It has to be modified. But let's see, assuming I still want to go through this, or I didn't even check this, and I take this as my assumed solution. Let's differentiate it twice. If you differentiate sign, you're going to get cos. So 4a cos 4t. This gives me negative 16a sine 4t. So equation 1, equation 2, equation 3. And then we do a substitution into a differential equation. So substitute. The differential equation is y prime prime minus 6y plus 25y is equal to 2 sine 4t. I'll quickly do the substitution and factorization. When you do this, per my simple workout, you are going to get they are all in terms of A. So you have, let me check. I'm going to get 9a sine 4t plus plus 4 cos 4t is equal to 2 sine 4t. Now we compare coefficient as we always do. You realize that if I want to compare that of the sine 4t, I'll have 9a is equal to 2, which means a is equal to 2 on 9. If I want to compare that of the cos 4t aspect, I'm going to get 4a, sorry for that, 4a is equal to 0, which means a is equal to 0. I can't have two values of a. The undetermined coefficient, the coefficient that has been introduced, a, must have a unique solution. That is why this guess function was not a suitable one, because it had a copy in the YC. So I simply went ahead to prove that it wouldn't work. Hence, it must be modified. So modify my YP. How do we modify this? Because at this final point, let me change the pen here. Because at this final point, we had some cos term in. I need to find a way to include this cos term, so I can easily compare it at this point. So my modified YP, I'm going to introduce a cos part. So aside the sine, a sine 4t, I'm going to add some b cos 4t. So I can cater for this aspect of the equation to have a unique solution. You realize there's a sine, there's a cos, so I need to bring in the cos factor to be able to compare. If this is my new YP, then I can find the first derivative, so this becomes minus the second derivative, 16a, so minus 16a sine. Please don't forget your differentiation of cos and sine. So this is my new equation 1, equation 2, equation 3. I need to substitute this into the differential equation. Again, I will write the differential equation for you to see. It was given as y prime prime minus 6y prime plus 25y is equal to 2 sine 4t. So I'll change the pen here again. I substitute this into the differential equation and I'll have to factorize or simplify. If you should do that very well, you end up getting a simple expression in terms of a and then that of the cos. You end up getting 16a. So let me just write the final thing. I have 9a sine 4t plus 24b sine 4t plus 9b cos 4t minus 24 cos 24a cos 4t is equal to 2 sine 4t. If you do the substitution very well, now I can compare coefficients. If I want to now compare that of the sine 4t part, I'm going to get 9a minus 24b to be equal to 2. If I want to compare the cos 4t part, I'm going to get negative 24a plus 9b is equal to 0. Now I have two systems of equations to solve. You know what to do here. You can use elimination method or substitution method or the matrix approach, any way to find a and b. Now the difference here is that now we have other variable to compare it, so we don't have this issue anymore. And then if you work it out very well, you'll find a solution for a and then b. So a should be something, b should be something. That can help you to rewrite your yp with the values of, so here is sine, then you can rewrite your yp to have its particular solution. Don't forget, when you are done, the general solution, so let me say ygen is your yc plus yp. Okay, now the last example on another modification. I want to solve a second order again because I don't have to differentiate so many times. I'm still taking some exponential function here. So the fourth example is still on exponential functions when my gt is exponential function. You now have to find my complementary solution by setting the differential equation to 0. I find my auxiliary equation, that is lambda square 2 lambda minus 3 equal to 0. I can find the factors here. It will be lambda equal to 1 lambda plus 1 lambda minus 3. Let me see, lambda square. No. So it has to be, it should rather be plus here and then minus here. So lambda 1 is equal to 1. Lambda 2 equals to negative 3. And I can write my solution as C1. It's in terms of t, yes, in terms of t, not x, plus C2e negative 3t. The next thing is to find your yp by stating a copy of your gt. My non-homogeneous term there is 4e for exponential negative 3t, and so a copy of that becomes some a e negative 3t. So I do the check. Do I find a copy of that in my complementary solution? Yes. So it means that is a bad guess, just as we did in the previous example. Hence, you must modify your YP. And how do we modify this? The way to modify any other functions is to multiply by the independent term. So it's better to have a multiplicity as ate negative 3t. Then I don't have it in there. It is yes because c2 is a constant as a. But in this case, if I will compare it, my c2 is not the same as a times t. Even though I have the exponential function there, this a is a constant multiplying a variable. So in this case, it is not the same. Alright. So I can go ahead and differentiate it twice. Now if I want to differentiate the first one, you realize that I have a t here, I have a t here. You have to use the product rule. The same thing will apply here. You have to use the product rule. And so that is with the modification. You don't forget the steps. Ensure that your guess is not in the solution of your YP. And that brings us to the case where we can have well-defined guess functions. Sorry for that. So when I come to my figure 2 here, the table, it has given us well-defined guess functions pertaining to our homogeneous terms. Let me move to the next sheet. So it says that if you have an exponential function as a, I think I have to change the pen. Let me use green here. So it says that if I have a source term, I want to know the guess. That is the YP. If it's of exponential function, so let's say some BT, you can simply go by AEBT. If it's a cos function, just add the sign to it. So cos AT plus sine AT with the coefficients B and then A. If it's simply a sine function, again use the same guess function here. If it's a combination of districts, use the same approach here. If it's a polynomial, where we took an example, it will be an increasing order. Sorry, a decreasing order of this. So it becomes a xn plus b xn minus 1 plus c xn minus 2 through to you get, let's say, z x to the power 0, which is just your z. So you reduce the powers of the polynomial. This is also simply to say that if I have, let's say, 2x squared minus 2, because the highest order here is 2, it means I move from ax to 2 to bx plus c, reducing order. If it is 3x cubed, I move from the cube, then I go to the square, I go to the x, and then I go to just d. This is how my guess function will look like. If it's to the power 4 in that reducing order, so ax to the power 4, I assume if it's just even this way, x4 minus 1, because of the 4 here, I have to go through this. So cx squared dx plus e. This will be my trial function for that simple GT. So that's why I say it is the decreasing powers of the function. Now don't forget the rule. We can also have combinations of the non-homogeneous term, and then you have to add up. And so that brings us to the end of method of undetermined coefficients. So I have a modified rule here. It says that if any term in the initial guess is also a solution of the homogeneous, so if I have a guess and I can find it in the homogeneous solution, please don't use it. Do what? Modify it by simply multiplying your guess by t. So t times yp. This should be the modified case. And so nothing in the modified should be in the yc. If I modify this and it is still in my yc, I have to multiply by t squared of my yp, and I have to compare with my yc. It shouldn't be equal. If it's equal, I have to multiply by t to the power cube of my guess function. Anything to ensure that your yp's are not found in the complementary solution. That is how method of undetermined coefficients is used. So please take your time and go through this video and understand everything being said here. On that note, we'll leave it here and then continue with the variation of parameters in the next set of videos.